No, this angle theta is the angle between resultant moment and principal axis. It has nothing to do with the horizontal axis. For example, some of the students were getting confused that this angle was the angle of resultant moment with respect to the principal axis. But if you see in this figure, this was a symmetric cross section. Okay, in the symmetric cross section, obviously your principal axis is also the horizontal axis. So this angle is with the principal axis, not the horizontal axis. So if in this figure, if you see that these are my principal axis, okay. So this is the, let's say, original horizontal axis, and this is the rotated horizontal axis or the rotated principal axis. So the angle theta is the angle between resultant moment and principal axis, which is this angle. And with respect to which axis? Principal. So I have to start from the principal axis and rotate or move towards the resultant moment. This is the resultant moment. Okay, so now if you see that in this figure, this angle is counterclockwise. So what should be the sign with this angle? Let's say if this angle is 10 degree. So I have to put in the negative sign. And when I apply this equation of tan beta, I have to put tan of negative 10. So is there any confusion or any other question about this angle?
सर अगर हम ये z एक्सिस से एंगल लें तो फिर तो वो क्लॉकवाइज हो जाता है और फिर एंगल चेंज हो जाता है.
Okay, now if you see in this figure, the angle was with which axis? The horizontal axis or the horizontal principal axis, right? In this figure, there are also two principal axes. One is the x principal axis and one is the y principal axis. But this angle is with the horizontal principal axis, right? Is this thing clear? Okay.
सही, लेकिन इस केस के अंदर
Yes. Yes, let me.
y से ले रहे हैं ना.
Yes. Now, okay. In the case of symmetrical section, the angle was with the horizontal principal axis. Now, if you see that in this figure, I have two principal axes. One is this y dash and other one is this z dash. So y dash is which principal axis? When I have rotated this horizontal axis into this position, so can I say that y dash is my inclined horizontal principal axis? Right? Y is the orientation of this horizontal, y dash is the orientation of this y axis. Did you get my point? I think it was Harun. So,
yes, sir, sorry.
Sir,
have you got my point?
सर अगर आप काइंडली दोबारा एक्सप्लेन कर दें, डिस्कनेक्ट हो गया था कनेक्शन.
Okay. In the case of symmetrical sections, the angle was with the horizontal principal axis towards the resultant moment. Now, in the case of unsymmetric section, we have to apply the same condition. The angle between the horizontal principal axis towards the resultant moment. Which one of these two is the horizontal principal axis? From y dash and z dash, if you see. Now, y dash is the orientation of this horizontal original axis, right?
अच्छा सर, सही हो गया, सही है.
So I have to take the angle with respect to the orientation with respect to y dash axis because it is the orientation of this original horizontal axis, right?
Yes, sir.
So this is the thing.
सर
Yes.
आपने तो ये डायरेक्शन इसकी क्लॉकवाइज नहीं ली y को, अगर हम y डैश ट्रांसफर करें तो
Clockwise. Which direction?
पॉजिटिव होगा फिर.
Which direction is clockwise?
आपने इस रोटेशन जिस तरह दी है क्लॉकवाइज दी है ना, y अगर ओरिजिनल
Yes.
एक्सिस है y डैश.
Yes. Yes. So again, I am telling you that what is this angle theta? Angles between resultant moment with respect to principal axis. Okay. So it doesn't matter कि इसकी rotation मैंने क्या दी है, y की या y dash की क्या rotation है, मुझे angle चाहिए between resultant moment with respect to the principal axis. So what is the angle of resultant moment with respect to the principal axis? This one, right? Usman.
सर इसमें हॉरिजॉन्टल एक्सिस तो z एक्सिस नहीं है इसमें.
In this question,
Yes.
this is the horizontal axis, this y axis. This is the vertical axis, z axis. These are the original centroidal axis, let's say. Okay, tell me why are you thinking that horizontal axis is z axis? Usman, can you hear me?
जी सर.
Why are you thinking that z axis is horizontal axis?
इसमें जो प्रिंसिपल एक्सिस तो ये नहीं होगा हॉरिजॉन्टल, अगर z एक्सिस होगा इसमें.
Z axis is the horizontal axis.
ये इधर जॉन साहब ने शो किया प्रिंसिपल एक्सिस z में.
This one.
इधर नीचे जॉन
This
सर
one.
ये. Yes.
This one. Why it should be the horizontal axis? My original horizontal axis was y axis, right? This
Yes,
y
sir.
axis. So for principal axis, because this is an unsymmetric section, I have to rotate these original horizontal axis at some inclination to find out the inclination of principal axis. So let's suppose for this case, the principal axis are y dash and z dash. Okay, that means that I have rotated this original y axis and z axis at an angle of some or in the counterclockwise direction to get this y dash and z dash axis. So what will be my horizontal axis in case of inclined case? This y dash, right? Because y dash is the rotation of this y axis.
Yes, sir. Please.
So that is why I am taking the angle or inclination of or I am taking this angle theta with respect to the principal axis.
Okay.
Is there any confusion? You can ask if it's still not clear.
No, sir. Clear हो गया.
Okay. So is there any other question about this one? So in the next question or in the next derivation, which was about the calculation of this YB and ZB distances. So this was our figure that we used, and if I show it over here, now in this figure, just remember one thing, that this angle theta is the angle of horizontal axis or of the principal axis with respect to the original horizontal axis, right? So let me show it over here. For example, this is the Z section, okay, and these are my original, let's say, horizontal axis. And when we did the derivation for this one, we assume that these horizontal Z dash and Y dash axis are rotated in the counterclockwise direction to get these two principal axis, that is Z axis and Y axis. So now in this case, now this angle theta has nothing to do with this one. This angle is, if I define, is the angle of principal axis with respect to original horizontal axis. Okay, so now in this case, if you see that the orientation of principal axis, that is Z axis, with respect to original horizontal axis is counterclockwise. Now, whenever it is counterclockwise, I have to substitute the angle as, let's say if this angle is 20 degree, I have to substitute positive 20 in the calculation of YB, that was Y dash B dash cos of theta or Z dash B dash sine of theta. Okay, so this angle theta will be positive. Now let's suppose if there is some question in which the orientation is something like this for the principal axis. Now, it might be possible that this is the z-axis, and obviously these two axes will be given to you. That which axis is this one? This axis can be y dash or whatever, but this will be provided that this is the z-axis and this is the y-axis. So by z-axis, it means that this is that originally this axis was horizontal. Now I have rotated the horizontal axis at some angle. So now in this figure, if you see that the angle theta of principal axis with respect to horizontal axis is in clockwise direction, right? So in this case, if this angle is again 20 degree, I have to substitute this value as minus 20 in this equation, right? So any question about this angle?
सर क्या
Okay.
आप एक्सप्लेन कर सकते हैं कि जेड बी डैश वगैरह क्या चीजें होती हैं? वो थोड़ी सी क्लियर नहीं हो रही कि जेड बी डैश डिस्टेंस कौन सा होता है और वो किस चीज को रिप्रेजेंट करता है बेसिकली?
That okay, I will explain you from this figure. Now, for example, let's suppose I have to compute the stress at this point B. But in the case of original sections or in the case of symmetrical section, obviously my principal axes are straight. Okay, so I will directly take the distance from, let's suppose, this point to this point B, and this distance will be ZB. Okay, and from this point the this distance will be YB. This distance will be YB, and from this point to this point, the distance will be ZB. Okay. So now in the case of symmetric section, we directly substitute these two distances in our equation of flexural formula, that is my over I. We will directly substitute the straight distances. But in the case of unsymmetrical section, obviously our principal axis have now rotated at some inclination or at some angle theta. Now in this case, I have to calculate these two distances. So we did one derivation in one of our lecture to calculate, and we developed this equation that is yb is equal to yb dash cos theta and zb dash sine theta. So this equation basically states that if you know these straight distances to this point B, and you know the angle theta of the which is the angle of principal axis with respect to the horizontal axis, then you can directly compute these perpendicular distances YB and Z. This YB and this distance is ZB dash, and you can directly compute this YB distance and this ZB distance, which this one, which is by using this equation. And now in the case of unsymmetric section, you have to use these two distances in this flexural formula, not the straight distances, but the inclined distances, which are basically perpendicular with respect to our inclined principal axis. So in simple word, this YB dash and ZB dash are the straight distances to this point B, and this this YB and ZB are these inclined distances that we have to use in our flexural formula. Have you got this point?
Yes, sir. Thank you.
So any other question about this one? So next question that many students were asking was how to calculate the maximum moment in the case of simply supported beam. Okay, and how to determine that what is its direction. We solved one example for the case of, let's say, cantilever beam. This was our example. So in this case, if I have to calculate the maximum bending stresses, obviously I have to calculate the maximum bending moment in the case of cantilever beam. So for this one, we might have skipped the bending moment diagram. So obviously to find the maximum bending moment, you have to plot the bending moment diagram, and from that diagram, you will figure out that what is the value of maximum bending and what is its orientation. For example, for let's say for this cantilever beam, if this distance is 10 and this load is also 10, this will be my bending moment diagram. Now the value of this maximum bending moment is 100. Okay, so which force is producing this maximum bending moment? This 10 kilonewton, right? So, and in which direction? Obviously this 10 kilonewton is producing the bending in counterclockwise direction. So we have to take the resistive bending moment. Okay, so the resistive bending moment is obviously in the clockwise direction. So when I show this moment, let's say this is the cross section, and if I have to show this movement in the cross section, let's say it is in the first quadrant, I will place the beam over here and I will show it something inwards or pointing inwards because it is clockwise. And why have we shown it on the left side? Because there is a force on the left side of this beam which is producing the maximum bending, and that's why I have showed it on the left side. Now again I will resolve it into different component and continue with the normal calculation. Okay, so now let's come to the case of simply supported beam. Now in the simply supported beam, again you have to do the same step, plot the bending moment diagram. How you do it? If you have, let's say this is 10 and you will calculate these two reactions and you will plot the bending moment diagram. So what will be the diagram? It will be something like this one, and the maximum bending is occurring at the center. Let's suppose its value is 50. Now which force is producing this maximum moment? Can anyone tell me that?
Point load.
Sir, the reaction at the Vuju 5 wala reaction.
Okay. Yeah. So obviously this 5, for example, how will I get this value 50? I have to multiply this 5 with this moment arm and I will get this value of bending moment, so this maximum bending moment. So basically there is one force on the left side of this beam which is producing the maximum bending moment in the case of simply supported beam. So, and in which direction it is producing? Obviously it is producing the bending in the clockwise direction. For example, if I take the moment or multiply this force with the moment arm, the bending is being produced in the clockwise direction, and I have to take resistive bending moment. So the resistive bending moment will be counterclockwise, right? So if I have to show this on the cross section, let's say this is the cross section, and again I have to place my beam over this cross section, let's suppose just like this one, and I again will show this bending moment on the left side because the force is on the left side. So, and the direction is counterclockwise. So counterclockwise we show in the moving away from the center. So this will be the direction of resulting bending moment. And then again I will resolve this into two components and continue with my calculation. So any confusion about this one?
Sir,
Yes.
reaction on other side produce same moment, then why we not take these moment reaction on other side?
Okay.
Consider.
What was your sign convention when you were solving or when you were plotting the bending moment diagram? Obviously, you always proceed with the, let's say, you always proceed from the left side. Okay. So yes, the reaction on the right side will also be producing the same moment. So if I have to show this on the right side, let's do that. So this 5 kilonewton, and in which direction it is producing bending? Counterclockwise.
Counterclockwise. Yes.
So what will be the resistive bending moment?
Clockwise.
Clockwise. So the resistive bending moment is clockwise. And how do you show it in the clockwise direction? Pointing towards the center.
Yes.
Towards the center. So now my force is on the right side, right?
Yes,
So
sir.
I have to show the resultant on the right side over here, pointing inwards. So do you think that these two moments are same?
Yes, sir. Same. Yes.
So are you getting the same answers?
Yes, sir. Yes.
So you can select anyone.
Okay, sir.
So I am sticking with the left one to make things simple or to follow the same sign convention that you are already used to. Okay.
Okay, sir.
So is there any other question about this one? So these are the questions that most of the students have asked. If there is some other question, you can ask me now, because after that we won't have time to come back to this topic again.
सर एक फाइनल क्वेश्चन है कि सर जो मोमेंट है वो हमें कैसे पता लगता है कि हमें कौन से क्वाड्रेंट में लगाना है? लाइक अभी जो सेकंड क्वाड्रेंट में लगा हुआ है तो हमें कैसे पता होगा कौन से क्वाड्रेंट में लगाना है?
Okay, let's suppose that in this cross section you will be provided with one cross section, right? So let's suppose this was the cross section that was provided to you, and in this cross section the direction of applied load will also be provided. Let's say the applied load was somewhere over here. So by looking at this applied load, you will first find out that where is the axis on which bending is taking place. Now that axis is always perpendicular to this applied load. For this case, this axis will be somewhere over here. Okay, so now my movement or bending is always being produced around this axis. So I have to show these movement either in the second quadrant or in the fourth quadrant. Okay, so how will I determine? I have already shown you that you will again place the beam over here and you will figure out the direction of resultant movement. Now let's say in the second case or in another question, the applied load in the cross section is given like this one. So again, first you have to figure out that around which axis the bending is taking place. So that axis is perpendicular to this one. Have you got my point?
Yes, sir. Thank you.
So is there any other question? So if there isn't any question, we can conclude our class over here. And now I think you should be able to solve the assignment. And yeah, there was another question that some students are asking about question 10, that how to, I think it was like a rotated axis and the inclination was given to you something 1, 4, or I don't remember exactly. how to deal with this type of question. Now, I think only this question was different from what we have already studied in the class. So I would suggest you to try and do it like from your understanding or whatever.
सर आपकी आवाज नहीं आ रही। हेलो,
Can anyone else hear me?
यस सर अब आ रही है, पहले नहीं आ रही थी।
यस
सर
सर
अब आ
अब
रही है।
Okay. So there was one question just like this one, that we had a incline or a Z section on which this type of on which the inclination was given, and you were supposed to calculate bending stresses at, let's say, this point A or B. So this is probably one of the different questions from what we have already studied in this course or in this topic. So now I expect you to solve this one by using all the concepts or applying all the concepts that we have already discussed. And don't worry about the answer. Even if you get the wrong answer, it's fine. At least you should try it yourself. And after you submit your assignment, we can have a 10 to 15-minute session to discuss this question. All right. So if you have any other question, you can ask me.
एक्सक्यूज मी सर, बेंडिंग हमेशा
Yes.
न्यूट्रल एक्सिस के अबाउट होती है?
Bending is about neutral axis. I would say no. Neutral axis can change. Actually, the definition of neutral axis that we have studied in this course also was that the neutral axis is the one on which the stresses are zero. Okay, it has nothing to do with bending, nothing to do with bending moments or where the load is acting. It is the axis on which the bending stresses are zero. Bending is around the axis that is perpendicular to the applied load. But obviously, you are asking this question because previously you were solving the
सर आवाज नहीं आ रही आपकी।
हेलो,
लगता है लाइट चली गई है। क्या सीन है यार?
बस लीव करो, वैसे भी लेक्चर ओवर है।
बुखारी मरब्बे जाके बैठा है क्या? इतनी आवाज आ रही पीछे से।
नहीं नहीं,
Can you hear me now?
Yes, sir.
Yes, sir.
Yes,
Okay.
sir, we can hear you.
So the question was that whether the bending is always about the neutral axis. So in the case of symmetrical cross section, when the load was acting on the principal axis, the bending is being produced or was being produced around the principal axis. Now this principal axis or around an other principal axis. Now this principal axis is perpendicular to this applied load. Okay, so from this you can deduce one conclusion that bending is always being produced around the perpendicular axis to the load. Now this principal axis was also the neutral axis, principal axis, centroidal axis. Okay, so it was doing the role of three axes basically. So in this case, obviously the bending was around the neutral axis. But let's come to the question of, let's say, unsymmetric section. Or for example, for this section, and in this case, let's say the load was being applied around the or in the inclined direction. Now, in this case, the bending is being produced around an inclined axis or an axis which is perpendicular to this applied load. So now first thing is we have to resolve this bending moment onto the principal axis, and then if you see that in this case we have two neutral axes, because in this case the bending is being produced around two principal axes. So obviously there can't be two neutral axes. So that's why the definition of neutral axis is the one on which the stresses are zero. So we compute another axis which may be somewhere over here, and on this axis the stresses are zero, and that is how we determine or derive this formulation over here. In this formulation you have seen that we have assumed that the bending or the bending stress was zero on the neutral axis, and based on this uh, condition we have computed the inclination of neutral axis with respect to the horizontal axis. So it has nothing to do with bending moment. Neutral axis is the one on which stresses are zero. Have you got my point?
Yes, sir.
So is there any other question? Or we can conclude this question in this way also, that the neutral axis is the principal axis, or neutral axis can be the principal axis, but in this case there are two principal axes, so that's why the neutral axis is different. So for example, in this case, if the bending was produced around one of the principal axes, then this would have been our neutral axis. So it can be true in some cases, but it is not a generalized statement that bending is always produced around the neutral axis. So is there any other question? So if not, I will conclude this session over here and try to solve the assignment by today. And from tomorrow, we will move on to the topic of cylinders. So this topic is concluded for now. So thank you very much and take care. Allah Hafiz.